In this video, we're going to be graphing exponential growth and decay functions. We're just going to focus on growth. You have a decay example in your notes. So I have the function y equals 2 times 2 to the x minus first power plus 3. Notice that that base in parentheses is a 2, which is why we will be having an exponential growth graph when we're done. So the first thing we do is we realize that just like with our other functions and transformations, that 2 out front, the minus 1 with the x, and the plus 3 all transform our graph the same way they did when we did absolute value and parabolas or quadratic functions. The 2 out front causes a vertical stretch. If it was a half, it would cause a vertical compression. The minus 1 up with the x does the opposite of what we would think. It moves the graph 1 to the right. And the plus 3 does exactly what we think. It moves the graph 3 up. So first we focus on our parent functions. The function in the absence of all those extra numbers that are highlighted, which would just be 2 to the x. So let's set up our graph over here, and let's start with our parent function evaluated at 0, 1, and 2 to see what's happening to the right, and negative 1, negative 2 to see what's happening to the left. When we plug in a 0, we get 2 to the 0. Anything to the 0 power is 1. 2 squared is 4, and 2 to the first is 2. 2 to the negative first is 1 over 2 to the first, and 2 to the negative second is 1 over 2 to the second. That's our parent graph, which I'm not going to graph because I think it makes it a little messy. So now we're going to grab those highlighted numbers and do exactly what we're supposed to do. That minus 1 will affect the x's and the x's only, and it'll move them all 1 to the right. So we're going to add 1 to all of our x values. That 2 and the 3 will affect the y, so we're going to double or multiply by 2 all of our y values. 2 times a fourth, 2 times a half, 2 times 1, 2 times 2, and 2 times 4. Then we'll do the plus 3 last. We'll add 3 to all of those resultant y values. So when we add 3 to 2 fourths, we get 3.5. To 1, we get 4. To 2, we get 5. 4 plus 3 is 7. 8 plus 3 is 11. We're now done transforming our points. So we block that center column out of our brains, and we go plot the far left and the far right. First and foremost, though, we plot that horizontal asymptote, as you were told in your notes. That yellow plus 3 tells us where our asymptote or our fence is. Then we'll plot and plot and plot and plot and plot. So you'll notice I plotted the positives first. I did 2, 7 because 3, 11 is a little off my graph. And then I did 1, 5, 0, 4, which is our y-intercept there in white. And then I have negative 1, 3.5, and I just keep gliding along this horizontal asymptote, never passing it. I connect the dots, remembering to put arrows at the end, and then I answer all the questions. My horizontal asymptote is the horizontal line y equals 3. My graph is living above that line, so my range or my y values are y's such that they're greater than or equal to 3. The domain for all exponential growth functions is all reals, as told in your notes, and my y-intercept is where I hit that y-axis at 0, 4. So remember, it starts with the parent function, then we go to a table, and we perform all those transformations numerically, then we go plot, and then we answer the questions. And again, the most important thing is that horizontal asymptote at y equals 3 as indicated by this last number, which was called the k in your notes.